Hello and welcome to Creating Composite Numbers. This is Chapter 3, Lesson 5 from the Nelson Math Focus textbook. I'm Mr. Burko and welcome to my Mathcast. Our goal today is to multiply combinations of factors to create composite numbers. Now again, here's a lesson that we need to understand certain words before we go into it. A factor is a number that we can divide another number by. So for instance, if we take the number 8, we can divide or factor the number 8 by 2, because 2 times 4 will equal 8. We can also factor or divide it by 4, because vice versa, 4 times 2 equals 8. We're going to use factors to create composite numbers. Now a composite number is not a prime number. And now you'll remember a prime number is a number that can be divided only by 1 and itself. So for instance, 2 is a prime number, 3, 5, those are also prime numbers. But 8 is a composite number because it can be factored by more numbers than just 1 and itself. In case you're wondering what this thing is on our picture today, it's a big hunk of licorice. And you might not be too eager to talk about candy this soon after Halloween, but here we go. We have a character on page 85 whose name is Ole. And Ole is writing a story about a machine that stretches licorice. And so when you put licorice into one side of the machine and you press a number, the machine stretches to that many times the original length. So for instance, if he puts the licorice in the machine and he presses the number 2, then that stretches the licorice 2 times its original length. But if he puts the licorice in the machine and then presses 2, then 3, it stretches it 2 times 3, that's the length. Okay, so 2 times 3 is 6, so it ends up being 6 times the length. Now just to give one more example, if he had 3 buttons on this machine, for instance, then he pressed 2, 3, then 5, it would stretch it 2 times 3 times 5 times its original length. So 2 times 3 is 6, and 6 times 5 is 30, so that's 30 times the original length of the licorice. Alright, so Ole is trying to decide which buttons should go on his machine. And he needs to have it stretched from 2 times the length to 50 times the length. He doesn't want to have 100 different buttons on the machine though. He wants to see what is the minimum amount of buttons that he can actually put in. Now, he can also press combinations of buttons. So for instance, if he had 2 and pressed it 3 times, that would be 2 times 2 times 2, which is 6, okay? And then that would make it 6 times the length. So he can save himself a button here. In this case, if he only wanted to go to 6 times the length, he didn't need to have a 3, right? 2 times 3 is 6, but 2 times 2 times 2 is 6 as well, and he only needs 1 button. I hope you're starting to get this. We're going to talk a lot about this in our next lesson because we're going to give you a chance to explore this problem on page 85. I just want to plant a few seeds for you so that you can start thinking about it over the weekend, and then when we come back after the weekend, I want you to have a chance to try it out in class. Alright, so this is our question. What is the least amount of buttons that Ole needs to include on his licorice machine? And he needs to be able to stretch his licorice 2 to 50 times its length. Alright, give that some thought, and when we have our next lesson, we are going to go over this lesson in our groups, and we're going to see who can come up with the answer. Thanks for joining me. This has been Creating Composite Numbers, Chapter 3, Lesson 5.